Hello and welcome back to Human Evolution. Today we want to start talking about primates. And we've talked a little bit about some of our primate cousins, and of course I put this in because it's fun. We seem to be terrified of some of our primate cousins, but mostly what we want to do in this class is start to understand them. So when we look at primates, now again we've already talked a little bit about the prosimians and monkeys, and we'll do some more of that today. We just want to clarify what the characteristics are. Then we'll talk about apes, and of course we're going to focus on the other human ancestors and things like that. So that's going to be our focus. But anyway, I just wanted to put this in here so you can kind of see some of the taxonomy and the phylogenetic tree that we have going on here. And of course, this is our genus, and then here we are. These are obviously extant species, otherwise there would be more here. Okay, so what makes a primate a primate? Grasping hands. Now, some of those have opposable thumbs. We'll come back to that. But lots of them don't. Prosimians don't, for instance. But grasping hands, that's one. Fingernails, binocular vision, a larger, more complex brain, which means that we can learn well, no matter what who the primate is. Extended gestation and maturation, because as brains get larger, it is harder for the offspring to mature fully in the womb, so they're born fairly underdeveloped. And if you think about human babies, I mean, they can't do anything at all. There's a reduced reproductive rate because so much parental care has to go in, and that goes to that strong maternal bond that's on the last list. And then there's a high degree of socialization. Most primates, not all, but most primates actually live in very complex social groups. Okay, so here's just the hands. Now, these nails can be shaped like claws or whatever, but you can see that they actually come out of a nail bed, so they are in fact nails. Okay, binocular vision. This is really important because what we're talking about here is stereoscopic vision, which allows for depth perception, and we've talked a little bit about this before, but it is important for being able to judge where things are. And it's evolved in lots of groups independently, actually, but there they are, forward-facing, very exciting. Here's your first question. Forward-facing eyes typically indicate that an animal is an herbivore, omnivore, carnivore, prey, or predator. The answer to that is predator, because then you can see where something is to judge its distance. Now, does everybody that have forward-facing eyes, are they all predators? No, but that is a very common feature that you find in predators, and I think that's very interesting since we also have forward-facing eyes. Okay, so what are some primate adaptations to the various habitats they live in? Well, if you live on the ground versus in trees, you're going to need different structures. So when we talk about these arboreal primates, they have typically more erect postures, a little bit shorter spine, whereas the ground dwellers, they all have brachiated arms, but it's going to be much more pronounced, by the way, back to the brachiated arms, much more pronounced in your arboreal species because they are swinging from tree to tree, and that's what a brachiated arm does, and we have them too. It's very exciting. So ground dwellers typically have a broader, larger pelvis because they're walking more as opposed to hanging, and they are often what we call facultatively bipedal. Okay, and facultatively means that they can stand up and walk. It's not the normal way. They don't do it a lot, and it's certainly not something that they have to do. So facultative bipedalism. Okay, now about 30 to 35 million years ago, the early anthropoids, and we'll talk about what an anthropoid is in just a second, and the prosimians are all living in trees. Everybody is mostly arboreal. And this is about the time that you get the monkeys to split off from the prosimian groups. So at this point, we've got two suborders, the prosimians, which we've talked about, the lorises, the lemurs, the tarsiers, all those guys, and the anthropoids, who are going to be the monkeys, the apes, and the humans. Okay, which brings us to monkeys, who, as we know from some of our conversations in the past, have come to rule the day. So, monkey characteristics. They have the primate characteristics, right? They also have fingerprints. They have an opposable thumb. They have a very complex social structure with political and emotional ties and structures, and it's very interesting. They're also intensely curious, and a fun thing is they have tails. Old world monkeys have just a tail. New world monkeys have the most awesome thing on the planet, a prehensile tail. But when we start talking about that curiosity and that tail and all of that good stuff, I don't know why I said tail, not the tail. When we start talking about the curiosity and the complex social structure, these are things that are products of those larger brains, and it certainly is something where we see when primates interact with each other. These are baboons, by the way, and they are kind of less fun when it comes to interacting with people. As a matter of fact, they can distinguish men from women when they're attacking tourists, and they know that women with children typically have snacks, and so they will make a beeline to steal bags from women with children before they'll steal other things, because the probability of having snacks is much higher. And that's pretty astounding if you think about it. So about 20 million years ago, the Indian plate collides, smashes into Asia, and thrusts up the Himalayas. This is how we get these cute little baby mountains that, of course, are some of the tallest mountains in the world. The climate at this point becomes drier, and forests in Africa and Asia start to shrink. Okay, now this gives some increased savanna and grassland with fewer trees, which is going to later on set us up for a conversation about a very important human characteristic. But at this point, you have a new habitat to exploit. And so there are all sorts of new species that pop up here and there. And there's a decreased reliance on the arboreal environment, although lots and lots and lots of primates are still very arboreal at this time and are today. But we see this opportunity for new primates to evolve. Okay, so here is your next question. A decrease in forest area would result in the need for structures that allowed primates to travel longer distances on the ground, the ability to see in color, the need for large social groups for defense from large predators, bipedalism, or the need for larger brains. Well, color is going to be helpful no matter where you are. If you are diurnal, if you are nocturnal, it doesn't matter, no matter what your habitat is. The large social groups, well, arboreal animals have large social groups, and they will help them for all kinds of things. And so the other thing is large predators aren't necessarily going to start going after small primates if they've been going after large herd animals, right? So that's kind of a non-entity. We know that monkeys are not bipedal, neither are apes for the most part. And the need for larger brains, well, you can always use a larger brain. And those two things are not related. Being able to live in a savanna is not a pressure to select for larger brains. But you would need to be able to have structures that allowed you to actually walk on the ground, whether it's on quadrupedal or bipedal. So if you think about the lemurs that hop and skip along to the side, that would never work on the ground. So this gives some new structures that come up. All right, now about 15 million years ago, a new group shows up, and that is the apes, right? And gibbons, and then of course the rest of the apes. Gibbons are the first apes. They're sometimes called the lesser apes. They're cute. You can see no tail, right? And so this is going to be the start of the group that eventually produces us. Now, there is an interesting fossil that's been found that's called proconsul, and it's dated back to 23 to 14 million years ago, right about the time that you have the apes splitting off. These guys don't have tails. They have some of these heavier structures that show that they are going to be ground dwelling for most of the time. Not all the time, but I mean that they are living on the ground. They are able to walk. They are arboreal, but they are able to walk on the ground. So anyway, so this is probably going to be something that is ancestral or similar to something that is ancestral to the hominids later on. Okay, and let's talk about the hominids. The hominids are humans, chimps, bonobos, gorillas, orangutans, and their immediate ancestors. So anybody who's directly related in that line. And so when we look at that, take out gibbons. No gibbons. But orangutans, bonobos, chimps, and you can see bonobos and chimps are very close. They are very closely related. They only recently split off from each other, and so sometimes it's very hard to distinguish them. People for a long time thought bonobos were actually a subspecies of chimps. It turns out they're not. They're their own. And then, of course, here are gorillas and us. Okay, so what are some ape characteristics? Obviously, the primate and monkey features. And then I would like to point out, though, no tail. Apes do not have tails. So they do, however, have much more enhanced and extended parental care than the other primates. I don't know why I put primate and monkey features. That should probably just be primate features. Anyway, I'll change that in the notes. An enlarged brain, much bigger than the other guys, and this is associated with behavioral complexity of humans. What does that mean? This larger brain allows us to have all sorts of behaviors that other animals don't. And you find this in apes as well. And emotion, which is pretty exciting. Okay, so 10 million years ago, this is when you start having the split for the apes. 10 million years ago, the last common ancestor of orangutans and humans exists, okay? And so this is when orangutans split off. Somewhere between 7 and 9 million years ago, the gorillas split off of the line, right? Somewhere around 6 million years ago, chimps split off. And then we are left with the hominins. The hominins are the humans and the human ancestors. And we will start with the hominin features. Primate traits, right? So the primate traits, also no tail. Bipedal locomotion, reduced canines, larger brains, right? A collarbone, and an opposable thumb with fine motor skills, right? And so this dexterity is really quite helpful. Monkeys can pick things up, but apes, and especially humans, can really do very fine work with their hands, okay? So why humans have less hair than other apes? So why isn't that on the list of hominin traits? It is, but I forgot to put it there. There are other hairless apes. We don't know for sure if all the hominins were hairless. There's evidence that Australopithecus was hairy. Well, Australopithecus is another species that's a hominin, by the way. I didn't forget, it's not there. There are no other hairless apes living today. We're the only one. However, we don't really know about all the other hominins because we don't know what their outer parts look like. We only know what their skeleton looked like. And so we don't really have any idea. So there's no evidence that any of them were hairy, and we just kind of make assumptions based on what we know about chimps. So we really just don't know. Okay, so the geologic age ranges of the hominins, you can see we start about 7 million years ago. So this guy is older than the last common ancestor of chimps. So chimps are going to split off right about here. Gorillas are going to split off right about somewhere around here. Okay. And then we have all of these guys until we get to us. Wow, we have not been around very long, just as an aside. Okay, lots of other species were around a long time compared to us. Okay, so the oldest hominid in our line is going to be Sahelanthropus chadensis. And this guy is 7 million years old, and it's a mosaic of primitive and advanced features. So you get that small brain case, you get these chimp-like teeth, but you see a flat nose and a prominent brow ridge that are much more hominin than hominid, other apes, right? And I put hominid in here, hominin, hominid, those work. Those both work in this case, but this guy is a hominin. So this one is named Tumai. It was discovered in 2002 in Chad. It was a very interesting find. Now there's some other ancient hominids that we are not really going to talk about, but I think they're interesting. There's Auroran tuganensis, and he's about 6 to 7 million years ago, and this is probably what he looked like, very ape-like. Okay, very ape-like. And then Ardipithecus ramidus is also very ape-like, and you can see, here's the skeleton that we found. She has the long arms, just like this guy right here. And even though although you can see that she's probably a little bit less ape-like than Auroran is, but, still very ape-like, and look at those little apey feet. Okay, and how do we know that she had 8 feet? Because we have the bones. All right, now Australopithecus is the genus that is the predecessor to Homo, which is our genus, and they are the earliest well-known hominids. They lived between 1 and 4.2 million years ago, maybe as early as 5 million years ago. It's a bunch of different species. They're mostly found in eastern Africa. They are fully bipedal. Their brain is more chimp-like, but their teeth is more modern, more like humans. They exhibit sexual dimorphism to kind of an extreme. Males are actually about twice the size of females, and they are probably dependent on meat in their diet, and you can tell that by various features that they have that we're not actually going to go into until later. Okay, so the first Australopithecine that we know of is Australopithecus anamensis, and she or he is ancestral to Australopithecus afarensis, which we're going to talk a little bit more about. But this is what we know oldest. Okay, now Australopithecus afarensis is the most well-known of all of the early hominins, the Australopithecines. And they're very ape-like comparatively. You can see this is Lucy, and I'm going to show you a picture of her in just a second. Very small, like 3 feet tall. And so the males probably were closer to 5.5 feet. So that's also that huge sexual dimorphism. This is us. And you can see there's a mix of ape-like and human-like features. And again, we'll come back to that more later on. But we know more about Afarensis than we know about most of the other all of the other Australopithecines, actually. And so we have over 300 individuals, and so that allows us to do pretty good reconstructions. But the most complete skeleton that we found was Lucy, and she was found in the mid-70s. She's 3.2, 3.5 million years ago. She was actually found in 1974. And so you can see this ultimately looks like not a whole lot, but it actually is huge, and with the combination of all of the other individuals that we have, you get something that ends up looking very much like this. Okay, and you can imagine a scene with the Australopithecines hanging out in their, savanna, in their little groups, getting roots and digging for things and whatever, blah, blah, blah. It's a very happy time. All right, now, Afarensis is important because there was an adaptive radiation that occurs, and so Afarensis actually splits into 2 big groups, right? The gracile Australopithecines and the robust Australopithecines, which we'll talk about in a second. Afarensis is a gracile Australopithecine, and then Australopithecus africanus, 2.3 to 3 million years ago, is an offshoot of Afarensis. But the thing about Africanus is that we think that Africanus is ancestral to our genus, which means they would be in our line of evolution. They are a little bit more delicate than Afarensis. So you're seeing this trend towards smaller teeth, maybe some softer foods, whatever. And then you have your robust Australopithecines. These are an evolutionary dead end. They die out. And you can see, boy, look at that big, heavy face. You can see this sagittal crest where these huge jaw muscles are going to attach to. They are grinding and chewing hard foods. There are 2 species that we know of. And by the way, they used to be just Australopithecus, but as we've thought about it more and discovered more things and looked at the features, they've become their own genus. Okay, then there's this other guy about the same time is coexisting with Australopithecus afarensis, and that's Kenyanthropus platyops. And you see this same kind of mosaic, right? You've got small molars, that's human, flat face, that's human, and a small brain, that's ape-like. Kenyanthropus we don't know a whole lot about. We've got this lovely skull that you see here. But here's the thing. They are an alternate possibility for a direct ancestor to humans. And so this is another hypothesis about our own evolutionary lineage. So it is either Australopithecus, as far as we know. We've got Australopithecus africanus, which is the most commonly accepted ancestor. But then we now have this Kenyanthropus platyops, which may be a possible ancestor. Okay, and then this is just a comparison of the skulls. This, remember, is Paranthropus, skeletons, and I just wanted you to see it so you can kind of see that transition over time. And remember, these guys are an evolutionary dead end. Okay, so that's it for our conversation about primates and the early hominins. If you have any questions, please ask me at the beginning of class, and I will see you next time. Thanks for listening.